we will end this first chapter by a very short section, 1.3 Outlook to Approximation Methods. So recall this short piece from our view on this world, where we replace a linear but infinite dimensional problem. Now we would call it ax equal to b by linear and finite dimensional problem. And approximation means, well, you're usually talking about convergence. For convergence, you need a sequence. So you probably need more than one equation that replaces your infinite dimensional situation. So maybe you need a whole sequence, A1, A2, and so on, of operators that in some sense converge to your operator A, and then write down things like an x. Well, this is then of course not the x from above, let's call it xn because it will depend on n. And here the right hand side would be bn. Also this is something that approximates the infinite dimensional right hand side. So you have b1, b2, and so on, convergent to b. Okay, so this is infinite dimensional. These are all finite dimensional, and you do this for n equals 1, 2, and so on. So you solve many finite dimensional problems in order to approximate your infinite dimensional problem. And like we just said, we choose these operators an, we could call them matrices, finite matrices, so that they approximate my, let's say, infinite matrix A. We choose the right hand sides bn, which are finite vectors, so that they approximate the, let's say, infinite vector b. And now here's the big question. The big question is, assuming that the original equation up here, has a unique solution x, will then also my finite dimensional replacements have unique solutions xn, first question, and second questions, will also these converge to x? And this is exactly what we mean by stability, right? Remember that our hope was that our approximation, so approximation reflects the thing that we're doing here, is good enough so that also the solutions will exist and converge, and that is what we call stability. Okay, so you can see we are somehow encircling the topic and starting to understand it better. The question that is going to guide us through the next 4 weeks maybe is, what on earth do we mean by that arrow? How can a sequence of operators converge to an operator? How can a sequence of vectors, finite vectors, converge to another vector, maybe infinite vector, and so on? So these are big questions, okay? So convergence is a big issue, and we will have to stand that in chapter 2. Okay, so now you're getting an idea of what this course is about. It's obviously a maths course, but still I hope to see you around.